My people, it is great to see you. There you are. Here I am. Here this is, 7-3. All right, now we start to get into some legit stuff here today, folks. Well, I should say, the first two-thirds of this, easy peasy. The last third could be one of my favorite things to do. I know I say that about a lot of stuff, but the last part of today is these little fellas right here, exponential equations. All right, so let's think about this. We've solved a lot of equations this year, right? We've solved just your standard like one-step, two-step, multi-step, distributive property, proportion equations, literal equations, right? So we've done a lot of equations. Now we're starting to get big boy equations here. So these are equations with exponents in them, right? So we're going to solve these ones. We're going to solve quadratic ones. And they're a lot of fun. For me. They're not going to be fun for you for a while until we get comfortable with them. But the fun will have to wait until we can get through all this boring stuff. We got cube roots. The cube root is just like a square root. Okay, guys, a square root is what? Right? We don't really know what it does. We type that little weird symbol into our calculator. We type in 100, and it gives me 10. So your calculator will find roots for us, which basically is, hey, you want to know what number times itself a certain amount of times is a number? That's a root function, okay? So nth root, remember like our nth term for our sequences, okay? Nth root is like any root. So like the cube root, right, is 3. Cube is 3. So what number times itself 3 times, right, is 1,000. What number times itself 3 times is 125, okay? So these kinds of things. The nth root is just what number times itself, however many times you want it to be, is this number, right? So very weird calculations, kind of hard to grasp our mind. It's a very abstract concept, okay? Which we have many of these, all right? Rational exponents, we're going to learn about rational exponents, guys, like 1/2, 1/4, 2/3, 2/5, right? Not irrational exponents. We don't want any part of that, okay? So the first thing we're going to do today is literally just writing back and forth into and out of radical form and exponential form. This is not challenging at all, I think, for any of us, okay? Interesting to note, guys, if we take the square root of 16, or any number, right? We'll again, our calculator tells us what number that is. We can also take the 1/2 power. That will give us the exact same thing. So if you take 100 to the half power, you'll get 10. You take the square root of 100, you get 10. Try it out. I'm not making this up. Try it out on your calculator right now. Right? Yes, you can put the little caret, and then 1/2, probably easier to just go 0.5. Okay? It's the same thing. Well, we're going to just literally write expressions into and out of radical form and exponential form. So again, the 1/2 power, guys, is just the square root of something. So 81 to the 1/2 power can also just be written as the square root of 81. Of course, is 9. We all know that. All right? Interesting. How about these ones here? So 38, we could write that as 38 to the 1/2 power. Just like I could write this one down here to the 1/2 power, right? 32W. Now, should I write it like that? If you write that, I'm going to mark it wrong. Why would I mark that wrong? I don't know. Well, as it's written, only W is to the 1/2 power, okay? I need both of these to be to the 1/2 power. So how do we do that? Just like that, okay? So if we have multiple terms, look, this is a bear trap. I guarantee you there's going to be a homework question somewhere, and somebody's going to write like this. They're going to get all mad at me, okay? That's just the way it works, guys. You got to keep that in parentheses. Here, take the square root of 12m. Good to go. All righty. What else we got? Write this. Again, that's just the square root of 16. The nth root. Okay, so what happens when we don't have square root? We can still see that. Here is your Here is your cheat sheet, right? Boop, right there. Okay? A to the n equals b. And you take that n, that's the root you want of b, and that's going to equal a. Huh? It'll make sense here in a second. All right? Okay, so if I want the fourth root of 256, again, if we were writing this in exponential form, 256 to the what power? 1/4 power. Yep. Same thing here. This will be 15,625 to the 1/6 power. Fancy. This would be 2,401 to the 1/4 power. Now, what are these numbers? Guys, we can get these numbers in our calculator. I have to remember how to do that on this calculator. Let's see. Yep, there it is right there. So you make sure the 4 goes in first. Then you have your little root of 256. You get a nice number here. I got the number 4, right? So guys, on your calculator, it should go 4x, and then you type in whatever you want, okay? This tells your calculator, hey, I want a 4 to be where that x is, or the root. So I want the 4th root of 256. So what is it doing? It's figuring out what number times itself 4 times is this number here. And that happens to be 4 times 4 times 4 times 4. Okay. We want to know what number times itself 6 times is 15,625. Seems like it's going to be some multiple of 5, I bet. So anyway, so let's go figure this out. Yep, 15,625. Ha, it is 5. Look at that. Bam. Okay. Again, my calculator looks like this: 6x, and then the square root of that 15,625. Okay. You guys want to try 4 real quick? Sure. Why not? Seems like a good idea. The 4th root of 2,401 is 7. So again, these aren't hard to do, right? It's kind of nice. We finally get a break, something easy that's not terrible, so let's enjoy it. Okay. Maybe I can make all that go away. Okay, yep, here we go. This right there, good stuff, okay? What happens when we get, well, the ones are all easy. We're going to get some not good. We'll get like a numerator other than 1 here in a second, okay? But look what happens. The structure is still the same. 3 comes out here. It's going to be the 3rd root of this number, and then the 1 kind of disappears. It's actually there, but it doesn't do anything, okay? So once again, right, 8 to the 1/2 power was the same thing as the square root of 8. 8 to the 1/3 power is the same thing as the cube root, or the 3rd root of 8. Okay? So these are all, look, hey, this is a 3rd root. This is going to be a 4th root. This is going to be a 4th root, okay? If you want to just put, like, your calculator will still give you the right answer. If you put, hey, 1,331, like, ooh, no, don't be a highlighter here, bud. And then you do the caret and you put 1/3. Probably need to put that in parentheses. Your calculator is fine handling that. Look, I got 11. You guys see that? 11. Awesome. 2,401 to the 1/4 power. Nope, not 24.1. To the 1/4 power. Got 7. If you want to pause the video, try the last one. You most certainly can. We will get 1 more than 7. 8. Okay? So there we go. Again, these aren't too bad. When it says simplify, you just give me the number. If it says like rewrite it, then we would do that. Okay? So here's what happens when that 1, right, 1/3, 1/4. What happens when that 1 isn't a 1 in the numerator? Now it's 2/3. Watch what happens. Okay? The 3 still comes out if we're thinking about rewriting this. So it's the 3rd root, or the cube root of 8. Figure out what number that is. And then we raise it to the 2nd power. Okay? interesting. Or you just type in 8 to the 2/3. We need to be able to go back and forth, though. So we need to be able to write this in radical form or in exponential form. Again, exponential form, crew, has an exponent. Radical form has a radical. Okay? So I'll write these here. So this would be like the 5th root of 32. We'd come up with that number, whatever it is, and then we're going to take that and square it. Okay? This would be the 2nd root of 81, which is just the square root, guys, and then raised to the 5th power. This would also be the square root of 36, raised to the 3rd power. Okay? So if we were going to rewrite those, that's how that would work. Again, like I said, we can also just take these, do this. It's all going to give us the same thing. What do we get here, folks? 4. Okay? 81, that is that right there. Large number. Think about it, guys. This is 9. 9 to the 5th power. 59,049. 59,049. Okay. And 36, which is also to the 1.5 power, is 216. Right? Because this is 6, and that's a 3. 6 to the 3rd power. 6 times 6 times 6 is 216. Okay? So make sure, guys, we can write these either way. All right, again, these are all radical form in the top row. The first line here, all in exponential. No, that's backwards. These are exponentials. This is radical form. Okay? Can we please get to the equations? Yes. We made it. All right. Now, while I love me some proportional equations, I love exponential equations because they look super cool, don't they? Yeah, they do. So, guys, our variable, that what we are solving for, is in our exponent. 9 to some power equals 729. How do we solve this? Well, there's a good bit of guess and check, okay, in this. Now, we're going to go just straight guess and check on this one. Actually, no, we're not. We're not. We're going to do this the other way. So, the key to solving any exponential equation, okay, both sides need same base. Okay? What I mean by that is, what is my base on the left? 9. What is my base over here? 729. Those are not the same base. 9, 729. We need to write them with the same base. Okay? How do we do that? Well, it's real easy, guys. Look at the smaller number. Okay, leave it alone. Usually, okay? Look at the bigger number. I need to write 729 as 9 to some power, okay? I don't have a trick to figure out what this is. Like, literally, guys, I'm going to take my calculator, and I'm going to make an educated guess. 9 to what power is 729? Well, I know 9 to the 2nd power is 81. I wonder what 9 to the 3rd power is. Check it out. Okay? So there you go. 9 to the 3rd power is that. So this is how we do this. So 9 to the x power now equals 9 to the 3rd power. Here's the beauty of exponential equations. Once you have the base written as the same, we get rid of the base and we set the exponents equal to each other and we solve the equation normally. That's it. Now in this case, it's kind of weird because when I get rid of these, I'm just left with my answer. X equals 3. Cha-ching, all done. There it is, okay? So there's my answer for the first one. Okay? All right, I'm looking over here. So, we really escalate quickly on these, don't we, guys? All right, here's what we got to do on this one. Both sides need the same base, okay? I got a 16 here, I got an 8 here. So can I write 16 with a power of 8? No, because remember guys, I don't want to change this number. I need to somehow write this, right? 9 to the third power, and these are equivalent expressions. They're the same number, they're just written in two different forms. So 18 to what power is 16? Well, 18 to the first power, it's just 8. 18 to the second, 8 to the second power, that's 64. Okay? 8. Okay. Here's what we got to do. When this doesn't work, right, like it did here, we need to think of smaller numbers. Now I'm going to have to write both sides with a common number, right? And here's what they're always going to try to do. Your best friend is the number 2, guys. 2 to what power is 8? 2 to what power is 8? Well, that would be 2 to the third power, okay? I have not changed the meaning of the right-hand side of my equation. 2 to the third power and 8 mean the same thing. This is written in exponential form. That's why we call these exponential equations, okay? I need to write 2 to some power as 16. So 2 to what power is 16? Okay, well, it's just one more power than this, right? It's just 2 to the fourth power. Okay, now, what do we do with this 2x minus 1 guy? Well, it was in the exponent, and it's going to stay there. 2x minus 1. Okay, can you guys see that okay? Okay, now we're to the fun part. Okay, we have the same base. Get rid of your bases, set your exponents equal to each other, and solve for x. So 4 to the 2x minus 1 equals 3. Okay, we can do this now, all right? I'll distribute first. 8x minus 4 equals 3. I'm going to go ahead and add 4 over here. 8x equals 7. And x equals 7/8. Perfect. Not a great number, but I know it's the right answer, okay? So there we go. We're all done. How could you check this, right? Well, it's real easy. You would take 7/8 and you replace it here, okay? You would take 2 times 7/8, get that number, subtract 1 from it. That is your exponent. If you take 16 and raise it to that exponent, it will give you the number 8, okay? So that's how we can check it. Exponential equations, okay? Right with the same base. Again, here's another example. I cannot write 27 with a base of 9. It just doesn't work, right? Because 9 to the first power is 9. 9 to the second power is 81. We're always trying to write the bigger number with the smaller base. When this doesn't work, your second best friend is 3, okay? You know what your third best friend is going to be? 4. All right? All right, so I need to write 9 with a base of 3. So 3 to what power is 9? Second power, okay? Do not forget the 3x plus 1 part. Okay? We need to write 27 with a base of 3 to some power. So 3 to the third power is 27. Again, whatever is in the exponent, guys, I just put in parentheses, okay, because we're going to have to multiply it. All right, once we make it this far, right, this is, like, I feel like this is so cool to do. Don't ask me why, I just feel like it is. Once we get this far, we're home free, because it's just like solving any equation we've solved all year. Your bases cancel out, right? The exponents become set equal to each other, and we solve normally, okay? I'm going to distribute here. I'll call this 6x plus 2. That will be equal to 12, okay? I'm going to go ahead and subtract 2. You're going to find that with a lot of these, we're not going to get great numbers, right? This is, what is this, 10 over 6, which is really 5 over 3, or 1 2/3, okay? We're not going to get great numbers. That's because we're dealing with these exponents, right? Remember, I would take 5/3, multiply it by 3, add 1 to it. That power of 9 will be equal to 27 to the 4th power. Okay, if you don't believe me, try this out. Okay. All right. You get more of these? Oh, then there's this one. Oh, boy. Now, this could be fun, all right? Actually, I think this one's easier than the couple we just had. But it's got words in it, and that confuses everybody. Okay. The population of a culture that begins with 40 bacteria, ooh, gross, and doubles every 8 hours can be modeled by this. Hey, eventually we're going to write these later on this chapter. Interesting. 40 was here. Doubles means 2 here. Interesting. Right? Eventually we will write these. But for now they wrote it for us. So the population equals 40 times 2 to this t divided by 8 power. Right? Where t is the time in hours. Find the time if the population is equal to 20,480 bacteria. Sounds delicious. Okay? All right, so we have to substitute this value in for p and then solve this equation. So it looks like this. 20,480 is equal, right, to that. Well, this does not look like my other equations. Why not? Like, if you're not sure, go back and look at the other 3 that we did. I'll give you a clue. It's got something to do with this side here. Okay, it's this. That's our problem child right there. I need to get rid of the 40. Then it would look, if I could just make this array, look, that kind of looks like the other one. I know our exponent up here, we haven't seen division in yet, but we're gonna be okay with that. So I'd like to get rid of the 40. So how do I get rid of, look, we're just multiplying this number times this number. So let's divide. Okay, so I'm going to divide this by 40, right? I'm going to divide by 40 over here. We know that'll go away. I'm left with 2, and then this is still that t divided by 8 thing. I have no idea what number. 20,480. I mean, like, I could try to, I guess I could have divided that in my head. 1,024. Okay. All right, here, just for lack of room, because I don't have much room here, get rid of all this. T over 8 to the 2nd power equals this. Okay, now make this go away. There we go. All right, so we need to do what we've been doing, which is what, guys? Look, I like the fact this is a 2. Do you think this is a power of 2? I bet it is. I don't know what it is. This is where the guess and check thing comes in. Let's try 2 to the 10th power. Get out of here. Are you kidding me? This is like literally my first guess. Look at that. Got it. All right, so 2 to the 10th power. Here, I'm just going to go like this. You guys can write the other step. I just don't have a lot of room here, people. Okay? 2 to the 10th power equals 2 to the t over 8 power. Now, all we have to do here, just, hey, get rid of your bases. Set your exponents equal to each other, t over 8. Can you solve this equation? Of course we can. This is the easy part. Getting to this step is not easy, right? We had to divide by 40 and then guess and check to figure out what power of 2 was that 1,024. Right here, I'm just going to multiply by 8. 80 equals t. There you go. So find t. That's what we just did. So t is 80. So that means after 80 hours, population of that bacteria, whatever petri dish, culture, whatever it's in, is 20,480. That's kind of gross. Okay. This is a great page. Maybe, you know what? I bet you I left this page blank so that I could put the whole equation on there. I'm so dumb. All right. This one has the same structure to it, guys. Right? I want you to try this one on your own. It says the number of hits can be modeled by this, where t is the time. Find the time, just like we did, right, if the number of hits is this number here. So replace h with this number, 24,576. And this is 4t divided by 3. Okay? So go ahead, pause this. You guys try it. We'll come back. No, you're supposed to pause this. Go, pause. Go. Have fun. Okay, so maybe you're not back. Maybe you tried it. Maybe you didn't. Who knows? First step, divide by 6. I got to get my handy calculator out here. It's still too early in the morning. It's 10:30 now, guys. 2, 4, 5, 7, 6, and we're going to divide that by 6. So this turns into 4,096, and that is now equal to 2 to this 4t over 3 power. So we need to write 4,096 with a power of 2. Again, guess and check. Ooh, I went 2 to the 15th. Way too big. 2 to the 13th? Nope, it's got to be one less. 2 to the 12th. There we go. So 2 to the 12th is the same as 4,096. Okay? So 2 to the 12th equals 2 to this 4t divided by 3. Okay? Now, do what we've been doing. The bases are the same. Set the exponents equal to each other. So 12 equals 4t over 3. Okay? I can get rid of this in 1 or 2 steps. I don't really care. Multiply by 3. Multiply by 3. So call this 36 equals 4t. Divide by t. We get 9. Okay? Super. All right, guys. So there you go. So there was a lot of easy stuff filled in with some really hard stuff that we did here. But they're exponential equations. Don't be afraid of them. Find the right base. Okay? These will be the most weirdest looking equations probably that we solve all year. I think they might be the hardest. Right? Quadratic equations I don't feel are as bad because sometimes we just don't know what to do. We're confused because that variable is up in that exponent. We've never seen that before. Okay? But guys, just write each side with the same base, set the exponents then equal to each other. All right? If you need more practice, again, don't forget about the Skills Practice PDF on Schoology, as well as all of our bookwork and quizzes and everything else. See ya.